Good morning everyone. I am Dipanji from BSc Chemistry Honors second year. Today I am presenting the topic alcohols. Alcohols are the hydroxy derivatives of hydrocarbons. These can be classified as mono, di and trihydric alcohols. For example, methanol is monohydric alcohol, glycol is dihydric alcohol and glycerol is trihydric alcohol. CH3OH. It is methyl alcohol and it is monohydric. CH2OH, CH2OH, glycol. This is dihydric. This is glycerol and this is trihydric alcohol. Now we will discuss aromatic alcohols. Aromatic alcohols कौन से होते हैं जो कंपाउंड्स हाइड्रोक्सिल ग्रुप प्रेजेंट हो साइड चेन में, जैसे we will take benzene and hydroxyl group is present in side chain. Now phenols. In phenols, hydroxyl group is directly attached to the benzene ring. CH3OH. It is a monohydric alcohol. सैचुरेटेड मोनोहाइड्रिक अल्कोहल को हम एल्केनॉल्स भी कहते हैं. इनका जनरल फार्मूला क्या होता है? CnH2n+1OH. Now monohydric alcohols are classified as primary alcohols, secondary alcohols and tertiary alcohols. Now primary alcohols. Primary alcohols are those in which hydroxyl group is attached to a primary carbon atom, CH, OH, CH3. Now secondary alcohols. These alcohols contain the hydroxyl group attached to the secondary carbon atom. Tertiary alcohols. These are the alcohols in which hydroxyl group is attached to the tertiary carbon atom. CH3, 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 OH. Structural isomerism. Monohydric alcohols exhibit three types of structural isomerism. First is chain isomerism. This type of isomerism is due to the difference in the nature of carbon chains attached to the hydroxyl group. For example, CH3, CH2, CH2, CH2OH. It is butane 1-ol. And CH3, CH, CH3, CH2OH. 2-methyl propane 1-ol. Second type of isomerism is position isomerism. As the word position indicates, this isomerism is due to the difference in the position of hydroxyl group in the chain. For example, CH3, CH2, CH2, CH2OH and CH3, CH2, CHOH, CH3. In this OH group is present on the second carbon atom and in this on the first. So there is a difference in position. Now third, functional isomerism. Monohydric alcohols also exhibit functional isomerism with another class of oxygen derivatives, namely ethers. For example, CH3, CH2, OH, CH3O, CH3. Methods of formation of alcohols. The first method is reduction of carbonyl compounds. Alcohols can be easily obtained by the reduction of aldehydes, ketones, carboxylic acid, ester by a variety of reducing agents. For example, first reduction of aldehyde and ketone by catalytic hydrogenation. CH3 CHO plus H2. In the presence of nickel, it gives an propyl alcohol. Now second method is reduction with complex metal hydride. We can use LiAlH4 or NaBH4 aldehyde or ketone. In the presence of LiAlH4, we will get primary or secondary alcohol. Third reaction is Mervin-Pondoff-Verley reaction. It is a commonly used reaction for the reduction of ketones to secondary alcohols. Here the reaction. In the presence of aluminium isopropoxide, we will get secondary alcohol plus acetone. Next is reduction of carboxylic acid. Primary alcohols can be obtained by reduction of carboxylic acid by lithium aluminium hydride. In this reaction, the carboxylic part of carboxylic group is reduced to CH2 group, RCOOH. In the presence of LiAlH4 ether, we will get primary alcohol. A reduction of esters. Reduction of esters constitutes a convenient method of preparation of alcohols. First is Bouvelt-Planck reaction. Esters RCOOR dash, this bond will break, and in the presence of NaC2H5OH RCH2OH plus ROH. Reduction with LiAlH4. Esters can also be reduced with LiAlH4 to yield a mixture of two alcohols, RCOOR dash RCH2OH plus R dash OH in the presence of LiAlH4 and ether. Next is catalytic hydrogenation. On an industrial scale, alcohols are obtained from esters by catalytic hydrogenation in the presence of copper chromite catalyst. You can see the example: CH3 CH2 COO C2H5 plus 2H2 in the presence of copper chromite gives 1 propanol and ethanol. Then hydration of alkenes. Alkenes can be hydrated to form alcohols or either through addition of sulfuric acid by direct hydration, addition of sulfuric acid followed by hydrolysis. Bond CH2 plus sulfuric acid gives ethyl hydrogen sulfate, CH3CH2O SO2H H2O, then heat, we will get alcohol, ethyl alcohol. and side protect as a sulfuric acid. Now direct hydration. The more reactive alkenes directly add on water in the presence of acids such as sulfuric acid and phosphoric acid to yield alcohols. Will get alcohol. Oxymercuration, demercuration of alkenes. It is a very convenient two-step method for preparing alcohols from alkenes. Alkene plus H2O plus mercuric acetate HgOOC CH3 THF will get organomercurial compound. Plus CH3COOH. Then second step, NaBH4 demercuration, and it was oxymercuration. Plus Hg plus CH3CO negative. Hydroboration, oxidation of alkenes. When treated with diborane, BH3 called H2 alkene undergoes hydroboration to form alkyl boranes. The alkyl boranes are readily oxidized by hydrogen peroxide in alkaline solution to form alcohols. Thus, the net result of this reaction also is the addition of water to alkenes to form alcohols. For example, CH2 double bond CH2 plus B2H6 diborane, CH3 CH2 BH2. Again we will add ethylene, CH3 CH2 2BH, then again CH2 double bond CH2 triborane. Peroxide, we will get ethyl alcohol plus boric acid. Next is Grignard synthesis. By far the most important method for the preparation of primary, secondary and tertiary alcohols by reaction between a Grignard reagent and carboxyl compounds such as aldehyde and ketone. The addition product initially formed is decomposed with water, preferably in the presence of acid. The general reaction may be depicted as follows. RMGX is the Grignard reagent in the presence of dry ether. This is the additional product, and then we do hydrolysis, we will get alcohol. Next method is by hydrolysis of alkyl halide. The hydrolysis of alkyl halide with an aqueous solution of sodium or potassium hydroxide or most silver oxide result in the formation of alcohol. For example, RX plus KOH aqueous gives ROH plus KX. Now next, by hydrolysis of ester. RCOOR dash plus NaOH aqueous gives sodium salt of acid RCOONA plus R dash OH. The hydrolysis of ester with alkali solution is generally employed before the preparation of alcohols from naturally occurring esters. Next method is by fermentation of carbohydrates. This method has been used since very early time for a large-scale preparation of alcohol from sugar C12H22O11 plus H2O. Invertase enzyme, we will get glucose C6H12O6 plus fructose. Then C6H12O6 zymase enzyme 2C2H5OH plus 2CO. Physical properties of alcohols. Due to the presence of OH group in their molecules, alcohols are polar compound. Oxygen is more electronegative than either carbon or hydrogen, so that the electrons of the CO as well as its more OH bonds are displaced towards the oxygen atom. Oxygen partial negative, R partial positive, H partial positive. It have band structure. Now first property is physical property, physical state. The lower alcohols are colorless liquid and the higher members are colorless, tasteless, waxy solid. Waxy solid. Second is associated state. Hydrogen bonding. Since alcohols contain a hydrogen attached to a strongly electronegative oxygen, extensive intermolecular hydrogen bonding exists between alcohol molecules. For example, H. Alcohols exist in the form of associated molecules and not simple monomeric molecules. Now, boiling point. The boiling point of alcohols are much higher than those of hydrocarbon because of their comparable molecular weight and having hydrogen bonding. The highly boiling point of alcohols can be explained in the term of extensive intramolecular hydrogen bonding in alcohol. Large amount of energy is required to break these hydrogen bonds. So, boiling point of isomeric alcohols are in the order primary, then secondary, then tertiary. This is because of the isomeric alcohol, primary alcohol are most polar and form the hydrogen bond to the maximum extent as compared to secondary and tertiary. Solubility. The lower alcohols are highly soluble in water, but the solubility decreases with the increase in molecular weights. The high solubility of lower alcohols is due to the formation of hydrogen bonds between alcohol and water molecules. As you can see, the rapid fall in the solubility of higher alcohols is due to the fact that with the increase in the molecular size, the non-polar hydrocarbon character of the molecule become more dominating in comparison with the polar OH group. This leads to a decrease in the extent of hydrogen bond formation with water and therefore the solubility in water decrease. For isomeric alcohol, solubility increase with increase in branching. This is because of the reason that the branching increase, the surface area of the non-polar hydrocarbon part decrease. The higher alcohols, it may be noted, are more soluble in organic solvent. Next, density. Generally speaking, the density of alcohols is lesser than that of water, although it increases with the increase in molecular weights. Now, how can we distinguish between primary, secondary, and tertiary alcohols? There is a test which is known as Lucas test. It is the most convenient and commonly used method for distinguishing between different classes of alcohols. It consists of treating alcohols with Lucas reagent, which is an equimolar mixture of concentrated hydrochloric acid and ZnCl2. Appearance of cloudiness in the reaction mixture indicates the conversion of alcohol into alkyl chloride. A tertiary alcohol reacts immediately cloudiness appear immediately. Secondary alcohol react within about 5 minutes when the cloudiness appear. Within 5 minutes. And in primary alcohol does not react appreciably at room temperature, therefore no cloudiness appears. Now the important reaction pinacol, pinacoline rearrangement. It is a typical reaction, higher glycols involving formation of rearranged products. It was the first observed in the case of pinacol, that is 2,3-dimethyl 2,3-butanoidol, and hence the name pinacol rearrangement. It was found that on treatment with sulfuric acid, pinacol undergoes dehydration with molecular rearrangement to form methyl tert butyl ketone known as pinacolone. That is methyl tert butyl ketone or pinacolone, and it is pinacol. Many other vicinal glycols are now known to undergo similar acid catalyzed reaction. All these reactions are therefore collectively known as pinacol pinacolone rearrangements. Thank you.